Hi, this is Kapil Sharma, and this is ICP 06 submission for Big Data Analytics, which is having objective of using a different data which was provided in ICP 6 already and discussed for the text prediction using RNN or recursive neural network model. Okay, so and we have to make four changes to any layers or any parameters which we are using or which we have used earlier. Okay, so first step is to importing all the required libraries, TensorFlow, NumPy, OS time, and then uploaded file modern chronicle dot txt. This is txt format uploaded using Google Drive, and then reading it having 9 uh, 945,199 characters, printed first to 50 characters, then counted unique characters, so having 76 unique characters in this file, printed first 10 characters, and now for processing the data we are mapping strings to numerical representation, so creating two different two different tables. So one is mapping characters to numbers, and another one is to numbers to the characters. Okay, so now for the prediction task, what we will be doing, we will be predicting, like for each input character we'll be predicting the next character, so it will be like sequence length plus 1. So it will predict the output as the following character. So for that we will be training with the examples, and whatever sequence we are taking from the input file, we will be training our model, and then based on that we'll be predicting it. Okay, so now creating for the batch method, it will create like individual characters to the sequences. So here we printed each individual characters. Now we are converting it into sequences with desired sizes. So this is sequence. Now for each sequence we will be duplicating it and shifting it to form the input and target text. Okay, for prediction, right? So we will be having input text and target text. Now printing it, so the target text should be like sequence length plus 1. So p will be p should be followed by r, so and then r should be followed by o. So this will be sequence length plus 1. Now creating the training batches. So here the first change is I am taking training batch size as 128, taking buffer size as 10,000, and then creating dataset, and then building the model on it using TF Keras sequential, and here taking layers as layers of our model as TF Keras layers embedding, and then GRU, and then dense dropout layer, and then the final layer is the dense layer. So embedding is the input layer, the GRU is which is RNN or recursive neural network with the 1024 RNN units, and then dropout layer is having a dropout rate of 0.1, and then there is fourth layer, that is a dense layer. So there are four layers. So here the second change is adding activation layer as 10H in GRU, and then having kernel initializer as Glorot uniform, and similarly like recurrent initializer also as Glorot uniform, and then adding fourth layer as dropout layer with drop rate of 0.1 defined here, and then the fourth layer is the dense layer. Okay, so now building the model and then trying running it, printing the shape and size. So 128 is the batch size, 100 is the sequence length, and 76 is the unique characters what we were having, that is the vocab size. So now printed the model summary having four layers: embedding, GRU, dropout, dense. These are the shapes and these are the parameters of it. And now created a sampled index of the array, and now training the model for predicting each next character. So here printing the shape of that 128, 176, the same as what we saw earlier. And now compiling it, and then configuring using model checkpoint of TF Keras callbacks, and then executed the training model. Here took epochs as 10, as we are using GPU in Google Colab only. uh, Now for generating the text, we will be having RN network. So here it will be having batch size as 1. So taken the batch size as 1, and now this tensor shape will be used to build the model. And for the prediction loop, we will be having the number of the characters as 1000, and then evaluating it, and then for text generated, having a having a string which is defined as blank, and then defining as the taken as the temperature as 1, and now creating a model for our predictions, and then we will be just storing it. So here now we are printing the generated text. So taking a start string, we need to provide that as Tom, and then each character has been predicted by our model. So this is the final result of our prediction model using RNN, recursive neural network. Thank you.